Yes, now we are going to discuss the hydraulics application, the hydraulic application for power generation. We are doing research in various technologies using various designs. In this technology, we are using a flywheel. The flywheel is having, the mass is 800 tons weight, flywheel. This flywheel is rotated RPM 1500. This will rotate 1500 times in 1 minute. The weight is 800 tons. The diameter of this particular thing, okay, this is the radius. The diameter is 9 meters, round wheel. This is 9 meters round wheel. RPM is 1500. Weight is 800 tons. So when this is rotated at 1500 RPM, the torque generated is transferred inside a speed decreasing gearbox. So the torque of this particular system is transferred to a generator via media using a speed reduction gearbox. The reduction gearbox is making, this is the flywheel. The flywheel is connected to a gearbox. The gearbox outlet shaft, the inlet shaft is having 1500 RPM. The outlet shaft is having 60 RPM. So here the generator connected to this particular thing is 40 megawatts, and the 40 megawatt generator is rotated at 60 RPM.
Can you join?
Yes. This 60 RPM generator weight is 500 ton and the flywheel weight is 800 ton. The flywheel is rotated at 1500 RPM. The generator is rotated at 60 RPM. So the torque generated by the 800 ton flywheel is reduced to 60 RPM. Thereby, the 40 megawatt power generation starts generating electricity. So to rotate this particular thing, to rotate this particular flywheel, we are using 500 kW motors, 16 numbers. So 16 numbers put together is nearly how many megawatts?
40 megawatts.
The flywheel, 500 into 16.
8,000.
8,000 kilowatt is the power consumed by 16 numbers of 500 kilowatt motors to rotate 800 ton flywheel. So this particular flywheel is rotating constantly at 800 RPM, 1500 RPM, 800 ton. Thereby, the generator part, this is the flywheel, and it is connected to a speed reducing gearbox and to a generator. This generator is having a particular hydraulic application. And in the accumulator, 16,000 bar pressure is stored. 16,000 bar pressure is stored in the hydraulic application. The accumulator part is storing 16,000 bar. So in this sense, we are having excess amount of pressure in the accumulator. This accumulator is consuming 8 megawatts of energy. Total 16 megawatts is consumed. This flywheel is not connected directly to the generator. This flywheel is connected via media, a speed decreasing gearbox, a speed reducer. Here the speed reducer will keep on rotating. This inlet shaft of the speed reducing gearbox will have 800 ton, and 800 ton is rotated 1500 rpm by using 8 megawatts of energy or 8000 kilowatts of energy. So this part is separate, and when we are coming to this particular thing, this particular application will have a particular cylinder with a piston. The bore of this particular piston is 1.5 meter dia. The bore of this particular piston is 1.5 meter dia. The cylinder is 4 meter in length. The application of this particular system is having 80,000 ton pressure per square centimeter. 80,000 ton per square centimeter is the pressure applied on this particular generator part. The generator is rotated with the pressure of the hydraulic accumulator. So here the accumulator is consuming 8 megawatts of energy, and the accumulator is having the force to rotate the 40 megawatt generator. In turn, the 40 megawatt is generated constantly at one particular area. In 1 acre of land, we can generate nearly 400 megawatts to 500 megawatts of energy. Because the wheel diameter is 1.6 meter, width is 1.6. Width is 1.6 meter. So if we are having a 1 acre land, in 1 acre land, if we segregate into 4 sectors, this is 61 meter in length and in width, and 66.5 meter in length. So in this way, when we are talking about division of 61 meter, in one sector we are placing 1.6 meter flywheel, 1.6 megawatt flywheel. So in this way, here we are generating 40 megawatts, here generating 40 megawatts, here 40 megawatts, 40 megawatts, 40, 40. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 sectors will be getting in 1 acre of land. In each sector we will be generating 40 megawatts. So 40 into 12 is a total amount of energy generated on this particular sector of 1 megawatt, using 1 megawatt. So if a densely populated area is there which is having the necessary for consuming electricity, so by using 1 acre of land we can give electricity to nearly 10 to 20,000 of houses every day. 10 to 20,000 houses can be covered in this particular area, and the megawatt generated is 480 megawatts. The consumption is 480 megawatts in this particular sector. So 16 megawatts per sector, 16 into 12, 16 megawatts per sector into 12 sectors. So the energy consumption 192 megawatts is consumed, and 480 megawatts is generated. In this way, this particular system is useful to balance the grid and the peak load systems in this particular sector. The grid will be having no the grid cannot be forced into overloading capacity. In this way, the grid will be balancing the part, and less amount of electricity is generated in this particular sector. So for sale, we are having 288 megawatts for sale per hour. In this way, the hydraulic application is used for power generation. The power generation is 24/7. The PLF is more than, the plant load factor is more than 100%. Here, the flywheel plays a very important part in generating the torque. The torque is transferred inside the gear, the reduction gearbox. From the reduction gearbox, it is coming into the generator. So the generator will be rotating only at 60 rpm. It is having 24 pole and 500 ton weight. So in this way, the 24 pole rpm generator is rotated at 60 rotations per minute. In 1 acre of land, we can do this particular system. So by doing this, almost all power sectors can have a relaxation period because thermal you have a lot of pollution. Nuclear there is a lot of danger of what we have seen in Japan in nuclear systems, and in solar and wind lot of areas are consumed. For keeping 1000 megawatt power plant, you require at least 50,000 acres or 1 lakh acres of land, because 175 square kilometers is the required area for generating 1000 megawatt of wind energy, and 5 acres per megawatt. If you want to generate 1000 megawatts, you should require 5 into 5,000 acres of land is required. So in that sense, large areas are getting wasted. The economy of this particular system gets back. It is going into back. Thereby, if you are using only 1 acre of land, any number of megawatts can be produced. Suppose in this particular sector we are talking about hydraulics. Hydraulic system is like this. So now we will talk about a different section where we will talk about generating. Yes sir. So now we will talk about the domestic sector area for power generation. For example, till as of today, there are so many architects, there are so many designers, there are so many engineers performing the designing of high-rise buildings, buildings from 5 stories, 10 stories, 20, 40, 50, 80, 100. People design buildings, but they have one constraint of major constraint is electricity. For pumping water to the maximum height using very little amount of energy. So these things matter a lot when you purchase a flat and when you purchase a particular apartment. So in this way, now we will show you how to generate your own electricity for high-rise buildings. The high-rise buildings concept is a very novel method. Till now, there is no such method in this particular entire engineering sector. So now, when I explain to you, this is a 10-story building. Okay, 10-story building. 3, 4, 5, 6, 7, 8, 9, 10. So this 10-story building should have enough energy to work on itself. So in this concept, what we do is, again we take 1 acre of land. The 1 acre of land is divided into 4 sectors. Okay, 1, 2, 3 and 4. 4 sectors are there. So here, as I said in the earlier system, 61 meter is a frontage and 66.5 meter is the width. So here what happens is, we are having a particular staircase design like this. Okay. The staircase is running like this in this particular sector. So each floor, if you are having each floor, one floor, you will be having one particular sector like this. You will be having steps and you will be coming down like this. So what we do is we remove these steps. We remove these steps. There are no steps in this particular area. Okay. No steps are constructed. The only thing what we have is an empty ramp, RAMP ramp. On this ramp, because when we are talking about 61 meter length, that is the width is 61 meter and the depth is the depth is 66.5 meter. So here when we are talking, it will be 66 meters. Okay, it will be 66 meters each side. So only one thing, only roof and steps, roof and steps. So on this particular system, the mechanism will be like this. you will be having a turbine, a generator. The water will flow through this because you are having an overhead tank in the top. The building top you are having an overhead tank. Here water is pumped. So when water is pumped, the reservoir gets filled. So in this way, the water is filled and the water is made to flow down. The flow water is 9,000 liters per second or 9 meter cube per second. So this 9 meter cube will rotate 158 kilowatt generator turbine. So this is a area where the generator is there, the turbine is there. So 9,000 liter comes in a Vril pool. This will be rotating and again it will be passing down. So what is this? The head is 3 meters. Head is 3 meters. Discharge is 9,000 liters. Gravity 9.81. Efficiency, that is mu, is efficiency is 94% max. So in this way we will be generating 158 kilowatt of energy per sector, because head into flow into gravity into efficiency is the formula for power generation. In this particular sector, for this particular thing, this is 3 meters, and when 3 meters energy is transferred by 9 cubic meters of water impinging the turbine, 158 will come. Again here 3 meter. So in the sense you are having 158 kW generated again by this particular water, because the water is coming down and it is stored. As soon as the pipe is filled completely, the valve opens automatically and the water impinges the turbine. So there the turbine rotates and generates 158 kilowatt. So the same thing is applicable. One generator here, one generator here, one generator here, one generator. Likewise, if you see, there will be 20 such areas where we can generate electricity in a 10-story building. There will be 20 such areas. If we are having 20 areas for power generation into 158 kilowatt, so what is the amount of energy generated in this particular system? Is it is
3.1 megawatt.
3.1 megawatt per sector. So one sector 3.1, the second sector 3.1, third is 3.1, fourth is 3.1. 3.1 plus 3.1 plus 3.1 plus 3.1. So here we will be getting 12.4 megawatts of energy generated every hour. So in the sense, the energy generated is 12.4 megawatts. For this we can use solar application. For this we can use wind power generation as a combination of hybrid, or we can use our own technology, the pumps innovated by me and my wife. So in this way, our pump consumes 1.6 amps and gives 10 LPS. One pump 1.6 amps and 5 LPS another pump. The 10 LPS is an improvised pump. The first pump we designed is 5 LPS. So if we take 10 LPS, 9,000 liters per second divided one pump 10 LPS, so 900 pumps. 900 pumps into 1.6 amps is 900 into 1.6 amps, that is 1440 kilowatt. So 1440 amps 1440 amps. So in this way, amp into volt into service factor by 1000 gives you the kilowatt consumed. So amp is 1440 into volt 440 into service factor 1.7 by 1000. So here we are getting 1077 kilowatt. This is the amount of energy we have consumed for pumping. So when we are generating from each sector 3.1 megawatt, the consumption of one sector is 1077 kilowatt. So 3100 minus 1077. So in this way, how much amount of energy is saved? 2022 kilowatts are saved per sector. So 2022 into 4. 2022 into 4, that is 891 kilowatt. So per hour you will be saving 8 megawatts in this particular sector. 8 megawatts every hour you can give to the vicinity. Suppose you are having 124 hours. So 809 into 24 is the amount of energy generated in one day. In 24 hours, how much of energy is generated?
194 megawatts.
194 megawatts is generated in this particular area every day. 194 in the sense 194,000, that is kilowatts. Okay, 194,000 kilowatts of energy is generated per day. So in this system, if we are using 10,000 houses divided by 10,000, 19 units is given per day for 10,000 houses. In this way, 10,000 houses can get electricity, that to 19 units a day, and in 1 acre of land this can be developed. In this way, the densely populated areas where there are high tension lines, the commercial part of this high tension lines can be very dangerous because lot of area is swallowed in this commercial sector where high tension lines are coming in between the living standards of the human survival areas. So in this way, this is small grid, smart grid. You don't require high tension lines. You don't require any of these supports called grid. That is, grid is interconnected power lines. Now, when we are talking about 1 acre of land in between 10,000 houses, government lands are many, defense lands are many, private lands are many. You just have to have 1 acre of land, and in this 1 acre of land, all the 10,000 houses sewerage water is taken into consideration. The sewerage water is used for power generation. So when people are living and people are using at least 10 liters a day per head, so 10,000 houses will have at least 4 people, so 40,000 people will take at least say 4 crore liters will come, or 40 lakh liters will come per day. So in this sector, if we are using the basement as the reservoir and store all the particular water over here, the excess water can be drained out through the normal system into the main reservoir, main outlet of the sewerage system. So in this way, water which is coming inside is filtered through sleeves, and the extra garbage what is there, it is removed. Only the water is getting collected inside. The water need not be purified. The water can be used as it is because it is humanly used water. So there will be no much problem in this particular sector. If we are using industrial wastewater and other specific waters where seawater and other things, the simple solution to this particular problem is you have to have a metallurgy analysis done for the particular pitting of this particular generator and turbine. When the corrosion is high, then the metallurgical department will guide us to to put epoxy paint or to have carbon steel or to have some other metal in this particular regard. So that problem can also be solved technically because engineers can do many wonders. So in this way, in 1 acre of land, we can have a particular solution which covers 10,000 houses, and the generated electricity is 24/7. The megawatt cost is 3.5 crores per megawatt. The unit cost is below 1 rupee. The manufacturing cost of the unit is below 1 rupee. In this way, we can give electricity for 2 rupees a unit in this particular sector of domestic or industrial or commercial or in any sector. 2 rupees is the maximum price. Thereby the human population can enjoy various happinesses by purchasing electrical goods, electrical appliances, and make their lives happy. Thank you.